Step 3 of the hypothesis test is showing the work much like we did with the sampling distributions. The thing to keep in mind is that we assume the null is true, that there will be no significant difference between the new and old medicine. So the sampling distribution shown is for the new medicine, but it's the same as the old medicine because that's what the null assumes. Only if the one sample mean taken deviates enough from the norm will we be convinced to reject the null in favor of the alternative. Our one sample mean was 47.7. How unusual is it? We should now show work a bit differently from the sampling distribution probabilities. We calculate the z-score for the particular sample mean. This is called the test statistic, and the APStat formula sheet will give you the basic formula, and it will list the different standard deviation formulas needed. Our parameter is the assumed population mean of 50, and our statistic is our sample mean of 47.7. Show the probability that z is less than or equal to our test statistic of z equals negative 1.84, and list the probability referred to as the p-value of the test. This problem was a one-tailed test. Only an extreme sample mean well to the left of 50 will convince us to believe the alternative is true. With this in mind, let's consider a two-tailed test. A two-tailed alternative is one that says the mean is not equal to 50 or whatever the parameter of the null is. This requires a bit more critical thinking, so follow me on this. The p-value assumes the null is true and calculates the probability of getting such an extreme result just due to chance. So in this case, with the mean of 47.7, we find that the probability of being at least as extreme in the left tail is 0.0329. But wait. Since the assumption with the p-value is to estimate the likelihood of an extreme result being just random fluctuation and tempting us to accept the alternative, and since the alternative is accepted either with a very low or a very high mean, we must double the probability for being below 47.7. This is because if it's all happening due to random chance anyway, a random sample at least that far above the mean would also tempt us to accept the alternative. Here's how you will know that the test is two-tailed and that you must double the conditional probability calculated. Look at the alternative hypothesis. If it is in the form mu not equal to the parameter, then an extreme sample mean above the assumed parameter or below it will necessitate doubling the probability of it occurring due to chance on either tail.